Hi, I'm delighted today to have the opportunity to talk to you about interdisciplinary perspectives on search. Before I begin, I'd like to thank SIGCHI for this Lifetime Research Award and the many colleagues who I've worked with over the years at Bell Labs and Microsoft and beyond, without whom this award would not have been possible. I've long been interested in how people retrieve information from external sources, whether these sources be people, books, or increasingly computer systems. The success of any information retrieval system depends critically on both the accuracy and efficiency of the underlying algorithms, and more importantly, on the ability to support people in articulating what they are looking for and making sense of results. In many ways, this talk could have been subtitled, "If Search Doesn't Work for People, It Doesn't Work." In the rest of my talk, I want to illustrate this with 3 lines of work that combine perspectives from human-computer interaction and information retrieval to design search systems. The first of these is something called latent semantic analysis, which I did very early on while I was at Bell Labs. And this effort was an attempt to remove communication barriers between searchers and authors. Stuff I've seen happened about 15 years later at Microsoft, and this work enables people to not just find information, but re-find information that they've seen before. And the final effort that I want to talk about is work on personalized search. And here the idea is to provide more contextualized and personalized experiences at web scale. My interest in search started after I finished my PhD and joined the HCI group at Bell Labs. This, I believe, was the first human-computer interaction group in industry. Tom Landauer, who is shown here on the left, was the leader of this group, and he was joined over the course of a few months by myself, Luis Gomez, and George Furness. At that time, most search happened in the physical world. People went to libraries, they browsed the stacks, and if they had a particular book in mind, they might use the card catalog to find it. People could search for phone numbers in the white pages or businesses in the yellow pages. Information was just starting to move online. This is a screenshot of a Teletel system that the phone companies were starting to deploy around 1980. It would be more than a decade after this before the first web page was created in 1991, and another several years before the first web search engines started to gain popularity. So my research started in these very formative years as information was moving from the physical to digital world. One of the first things that we discovered is what we called the vocabulary mismatch problem. When people seek information from external sources, there's a kind of impedance mismatch between the way that people who are looking for that information describe what they're looking for, and the way that people who created the information described it at the time. Fundamentally, people don't always use the same language. We saw this everywhere that we looked, whether it was trying to find information in the yellow pages, trying to find command names for operating systems like Unix. What's ironic is that we actually called this a phenomenon different names over the years, just exacerbating the problem that we were trying to solve. We called it vocabulary mismatch, verbal disagreement, or statistical semantics. We described this work at the 0th Chi conference. It was a conference on human factors in computer systems held in Maryland in March of 1982. You can see images of the conference. There are lots of men in suits and ties. Judy Olson is giving her talk using an overhead projector, and you can see the lovely early typesetting for our paper. The paper that we presented here was called Statistical Semantics. How can a computer use what people name things to guess what things people mean when they name things? Now, admittedly, this is a somewhat convoluted way of saying that there's a mismatch between how authors describe information and how people look for it. And the job of a computer system is to mitigate this mismatch. We went on to note that getting timely feedback was really in situ as people were using the system would be really important to build great systems. We said in the abstract, system designers are at a disadvantage in that they do not usually get explicit, immediate, and continuous feedback from users. Knowing this would help designers build systems whose information is accessible to the widest possible audience. It's really interesting as I was looking back on this to reflect how much this foreshadowed the importance of large-scale behavioral logs that are really key parts of modern web services. Nobody would design a web service today without the ability to understand how people are using it, and more importantly, to improve the system with this knowledge. Latent semantic analysis is perhaps the best-known solution to the vocabulary mismatch problem that I just described. It's based on a very simple principle that words which occur in similar contexts tend to have similar meaning. Take, for example, the words physician and doctor. They may never co-occur in a document, yet they keep very similar company. They both occur with words like nurse, patient, hospital, treatment, recovery, and so on. Using a mathematical technique called singular value decomposition, we identify patterns of word usage like this and used a lower dimensional representation to summarize these patterns. For those of you who know factor analysis, it's a very similar idea. Latent semantic analysis has been used for many applications. When applied to information retrieval, it allows searchers to find documents that contain the word physician even when they search for doctor. Jacob Nielsen and I used it to assign reviewers to submitted documents in CHI 1993. Tom Landauer and I used it to take the test of English as a foreign language, and LSA did about as well as the average test taker. Tom and I also used it to model vocabulary acquisition in children. The key to all of these and other applications is to learn a representation that mitigates the vocabulary mismatch between searchers and authors. As the name Stuff I've Seen suggests, search is not just about discovering new information, but also often involves refinding information that you've seen before. In order to help support people in refinding, we used two principles. The first was to unify access across different information silos. We wanted to make it easy for people to find email, files, web, without having to worry about where they saw that information. We also wanted to support people in specifying what they remembered about this information. When you've seen information before, you often remember when you saw it, who created it, what type of file it was, and so on. The first system we developed to support this was called Stuff I've Seen, and it is a very rich attribute-based view of information. It allows people to quickly slice and dice and pivot based on what they remember about a particular target, and do so in a way that allows them to hone in very efficiently. Time, it turns out, is a very important attribute, and so we developed further enhancements called memory landmarks that provide time-based anchors of salient events from your own photos, files, or significant news events that are happening in the world in order to help you get to the right kind of episodic information. This work highlights importantly that we need to support systems that enable people to discover new information as well as refinding information that you've seen before. The final example that I want to touch on briefly is work that I've done over the last decade or so on context and personalization in web search. It turns out that queries are exceedingly difficult to interpret in isolation. The query that I've shown here, SIGCHI, occurs in more than 3 million web pages. This task becomes much easier if we can begin to model who is asking the query, what they've done in the past, where they are, when it is, what events are happening in the world on that when the query is issued, and so on. So, if I issue the query SIGCHI, I typically mean ACM's special interest group in information retrieval, whose web page is shown below. If Stuart Bowen Jr. issues the query, on the other hand, Stuart was the Special Inspector General for Iraq reconstruction, he probably means the government site on Iraq reconstruction. And there are other contexts like this that can be quite useful in interpreting a query. It might be the immediately preceding search in a session. It might be location in some cases. It might be time of year or event in others. The bottom line here is that using a single ranking for every person in every context at every point in time fundamentally limits how well a search engine can do. Whenever the same query means different things to different people, you will not be able, by definition, to satisfy them all without some kind of personalization. I want to wrap up by talking a little bit about what's next in the world of search. We see increasingly people issuing search on the go in spoken queries rather than typed queries. More and more systems are anticipating what people might need and proactively finding that information rather than waiting for an explicit search query. And I think we're also seeing a very interesting convergence of digital and physical information as objects in the physical world become more and more connected. I think that we in the CHI community have tremendous opportunity here to shape how such systems are designed and developed. In just a few decades, search has gone from being a rather arcane skill to something that is a core fabric of people's everyday lives. Today, we all use search multiple times a day to find all kinds of information, to buy things, to monitor breaking news and events, to understand emerging medical conditions, and so on. And because of this ubiquity of search, I believe it's more important now than ever to understand and support people in creating, finding, and making sense of information. The CHI community should lead the way in shaping these information futures using the broad range of interdisciplinary perspectives that will be required to do so. And I want to give one last shout out to my many collaborators over the years. Thank you all for the inspiration and insights that you've provided for my work, which makes this award talk possible. Thank you all again, and I believe I now have time for a few questions.